This presentation is supposed to mess with your heads a little bit, at least towards the end. So we'll start slow and then we'll see how far I get with messing with your head. But the artificial intelligence is a topic that's very close to my heart because in reality this is, as Anna said, I lived abroad for 25 years and this is my first time actually working in a Polish company in Poland, kind of, with one leg at least. And I changed jobs 3 years ago, and I decided, one of the main reasons why I decided to join New Voice Media is because I believe I'm very fascinated by artificial intelligence, and I believe that the most interesting use cases where I could apply this, at least today, there's going to be tons of more, but there's a lot of interesting use cases that can be applied in contact center business, and this is the area which I believe is going to be disrupted and is being disrupted today by artificial intelligence. So that's why this topic is very interesting to me, and I feel like we're getting now where this is going to become a reality. So let's start. But first, let's talk about basically definition. What is artificial intelligence? So there's a lot of different definitions. I start with like a basic definition. What today really is artificial intelligence? And that's basically just a science area that applies analysis and logic-based techniques, including machine learning, to interpret events, support and automate decisions, and to take action. So today it's just a small piece of science. It's just maths, because you've heard probably a lot of hype, a lot of articles, news coming up, and we talk about the deep learning and neural networks, and it kind of feels like a little bit of a magic. But what today's state of technology around artificial intelligence is basically just maths. It's smart algorithms, well-written algorithms that use huge amounts of data, and at the end of the day, they just do a lot of calculation and some mathematical computation, aggregate the data and then spit it out. There's no magic whatsoever in today's artificial intelligence, but it'll become more interesting later. So, what is today's artificial intelligence? It will be often referred to machine learning, and the theme of machine learning kind of has the three main types of machine learning that are today known to the humanity, at least. So we have something that's called unsupervised learning. So unsupervised learning is have an algorithm that's looking at the data that is not labeled, unstructured data, and it tries to figure out some similarities in this data. A good use case for unsupervised learning would be something like anomaly detection, when you kind of have some data, fraud detection. It's used often in finance, where there's a normal way of using stuff, and suddenly something weird starts happening, and an algorithm that applies the unsupervised learning kind of detects this, and then it doesn't know what it's looking for, and then when it detects some pattern, it kind of spits it out, and then it can be labeled by whoever's using this data. So that's unsupervised learning. Then supervised learning is the second area, where you have the data is labeled. So you kind of apply this to the machine, large amount of data. You transform, let's say, pictures. For instance, like picture is a set of different pixels. So you need to transform this into some vectors with very complicated mathematical representation of the data. And then you tell the machine, okay, this set of data is a cat, if you feed it a picture of cat. And then this set of data is a dog. And once you've showed the machine thousands or tens of thousands of these different pictures, it will eventually, you show it another picture, you don't tell it it's a dog, and it will say, it looks like a dog, probably like 95%. Might have been, I don't know, my daughter dressed up as a dog, but it depends on how many pictures you showed it of the dog. But it'll kind of try to figure it out and tell you. So it starts to recognize new data without the label, and it's going to give it a label. So there's a lot of use cases for the supervised learning, obviously. Image classification being one, used very heavily by the likes of Google, Facebook when you upload pictures. There was recently some bug on Facebook, for instance, where it actually exposed what Facebook thinks of the pictures, so you could actually see, if you typed like special characters in your URL, you could see actually the descriptions of the pictures, what the AI of Facebook thought is on the picture. So that's the main use case. There's a lot of them, and then the third one, which is the most hyped today and most interesting from my perspective, at least, is the reinforcement learning. So reinforcement learning is it's like you know, like the Pavlov's thing, yeah? When you kind of you reward the machine when it does something good, and you punish it when it doesn't do well. So this is very good for like applying in games. So there was a lot of research happening, and I know there was some machine trained by Google, the science, they were still playing with it, but they for instance taught the machine to play some Atari games, like old games, for instance, Breakout. And so the machine didn't know what it's doing, just knew that, you know, if it scores a point, there's a point. If it does something, it doesn't score a point. And there's an interesting video. It's fascinating because you could watch it actually on YouTube, where you see like the machine, like there was like about 120 minutes of playing the game, and it was just moving. The Breakout game is like when you have the bricks on the top, and there is a moving thing at the bottom. You're trying to throw the ball, and it looked really like in the first minutes the machine had no clue what it's doing. So it's just like randomly moving the blob at the bottom, and suddenly it started hitting the ball. So like as you watch the video in an accelerated view, it kind of starts doing, you know, starts really playing like a human being. But the fascinating thing happens like after the first 2 hours. After the first 2 hours, it starts playing like a normal human. It's like you can't differentiate between, you know, a person and the machine. But they let it play more, and then suddenly what happened? Like after about 240 minutes, the machine learned the best strategy how to win the game. And this best strategy basically was to eat or kill all the blocks at the left side, make the ball fall on top of the wall, and then start kind of spinning against the wall and the back of the screen. Yeah, so this was the most successful strategy. And the fascinating part here is like no one taught the machine the strategy. No one, I mean, people, the players. There's a lot of computer scientists, computer geeks here. So you played it probably when I was younger. I did, and so you kind of figure it out eventually yourself as a human being. But this was like, no one programmed it. The machine just figured out the strategy for it by itself. So this is the reinforced learning, where you kind of have this set of teach the like machine does something and you tell it it's good or it's bad. And it started as easy as with games, but this thing is now really going way beyond it. I mean, it has real life examples. So for instance, like robot navigation, skill acquisition, it's like didn't put it, but like the self-driving cars, this is all using this type of technique. So that's the mainly three types of machine learning that's applied, that today is referred to as the field of artificial intelligence. You heard also about the neural network. So this is actually the type of an algorithm that is used mostly in the reinforcement learning. And neural networks has nothing to do with the brain, although it was inspired by the brain, by human brain. So neural networks consist of different topology of nodes. You usually have three types of layers. There's an input layer, middle layer, or hidden layer, and output layer. And like in a human brain, there's 100 billion neurons, and each neuron is connected with synapses with around 1,000 other neurons, and these connections is what forms the brain. It's the same thing in the neural networks that the programmers are programming. There's just those cells, different types of cells. I think I've seen recent topology. There's like about 30 different topologies. So how those cells in the first layer are connected to the second layer. You could have connections like between all of the layers, but not necessarily. So like some smarts in how to build this topology of the network. So that's the neural network. And you put in the input signals to it, and then it produces some output signal at the end. And the smarts here and what a lot of data science is required, and a lot of smartness is required is how do you transform some sensory data from, let's say, a car driving sensors, from a LiDAR sensor, into meaningful electrical signals that can be measured and then input into this engine of different types of neural cells. And then deep learning is another term that has become. Deep learning is just neural network that has multiple of those hidden layers. So it's not just 3 layers, 1 layer, 2, 3. In the middle is multiple of those layers. And they can get different functions. So one will, if it's like color recognition, picture recognition, one layer might be kind of smart and recognize colors. The other one may recognize like if it's a line or a person. So different attributes that kind of these layers are taking over. It's very difficult actually to visualize how this works. We just know it works. So it's interesting that we have algorithms, and even the best scientists don't really necessarily can explain how this works. So this is where the kind of a little bit of magic comes in, and people are a little boggled with it. But at the end of the day, it's just maths, nothing else. And so you probably, the developers among you heard of TensorFlow. So TensorFlow is basically an algorithm that applies this, implements the deep learning structures. So today it's in common use. And the statement I want to make is that AI is here and it's big. It's really, really big. Some of you maybe, everyone heard about it, but first of all, the most interesting use cases for AI are like customer-facing, customer experience for today. It's what today's research is saying. And 63% of companies think like their top 3 drivers for introducing AI is and where they can get most value is in customer experience. 66% of the top 3 reason is automation to eliminate repetitive tasks, and the third driver for adoption is to reduce cost, but that's a distant third. And the deployments of this technology are booming. If you look at, there was a survey from Gartner made in 2015 where they asked companies, are they currently using the AI technology or are they planning to use AI technology in the next 12 months? There was 10% total of companies that answered it. When they repeated the same survey in 2019, there was already 37% of companies that said either they are already using AI or they will be using AI in the next 12 months. So within 4 years, there was almost four times growth of companies actually using real use cases that are implemented in their business. So that's, and all of you know of Google Assistant, Alexa, Microsoft Cortana, all these smart assistants, that's all real use cases of AI technology that is deployed. Obviously the private is, because it's such a hot topic, the private investment is booming. I read some numbers that I think right now the investment, the private VC investment in AI technologies is over $10 billion per year now. It kind of reached this level. But that's not just it. On the deployments, for instance, on Wall Street, there's about 60% of all the trades that are happening on Wall Street are done using AI technology. So this is an area where AI technology has kind of overtaken the humans vastly. The number of patents in the last 4 years has grown by a factor of, number of patents since 2006 grew 5 times, and the number of AI startups just in the US grew by a factor of 20 in the last 4 years. So it's just huge. Yeah? So we have real deployments, we have private investment that's booming. Obviously governments are jumping on it, and if you look at the big countries, China, they have a national program called China 2025, which specifically, like if you read the executive summary of it, it says like China will be the world leader in AI technology. Guess what? Americans have the same thing. There is a national program. You can download it. It's available on internet. They have 8 priorities. Same thing. And the first page of the national report from North America says that North America, the United States, want to be the leader in AI technology. So governments are jumping on it. United Kingdom the same. They have also a special program. Germany have a program called Industry 4.0, which also defines priorities. So there is a lot of interest in the countries. The countries are investing in it. They are investing a lot of money in academia. There's huge amount of research. Actually, in the last 10 years, the number of research papers that were around AI grew by a factor of 15 as well. So it's just booming, and it creates a huge addressable market. And there is a Gartner report on the impact on industry that they expect in 2021. So just 2 years ahead, they think that the AI augmentation, which is using AI to kind of help people, is going to unlock $2.9 trillion in value. So this is more than the economy of a big country, actually. So huge numbers. So it's there. It's not going away. It's just a matter of time until this is going to be creeping into every area, almost every area that we experience. And as I said, it will start with the customer experience, because this is the best use case right now. That's most researched and closest to the real use. And this is actually an area where also Vonage are using the AI technology, where we have bots, speech transcription, natural language processing, these capabilities, so that you can know what people are saying when they're calling, and to automate some easy tasks. This is today we're using it, we're offering it to our customers. So another interesting chart that I wanted to show, this is a Gartner hype cycle that shows, this is as of July 2019, so it's relatively new. It shows some of the AI technologies and where they think is on the curve of adoption of technology. So you have they talk about the five different categories. You have the innovation trigger, where the first discoveries are happening. So there is a little bit of interest created in the market, then goes into the peak of inflected expectations, where the VCs are jumping on it, investment starts, there's more work happening. Then you go to the delusionment phase, where some of these startups die. There is not so much value that those AIs are creating. And then at the end of this phase, not all of the technologies, some of them are going to die before, but the ones that actually prove to have some value, they kind of go on to this slope of an and then reach the plateau of productivity. So this is when this technology becomes ubiquitous, easy to access, anyone can use it, anyone can get value out of it. So for instance, speech recognition today is, everyone knows it. All of you probably talk to your smartphone. A lot of you may have an Alexa, so that's where this technology, we use this also. So it's just there, quite reliable, we know it works. Gartner thinks that autonomous vehicles, it's already getting to, there's cars that drove millions of kilometers autonomously. Gartner thinks that it's going to take 10 years before they reach the plateau of productivity. We are working, for instance, in Vonage on NLP, machine learning, deep neural networks. This is currently the most hyped area. And we'll talk later about what starts to be interesting is this topic of AI governance and artificial general intelligence. I'll introduce those topics later. So we were talking about artificial intelligence, but what is intelligence? So this is where I kind of will start messing with your head, I hope. I like the definition of Max Tegmark. This actually, his book inspired me to do this speech. So this is a quite well-known futurist, and he's been thinking of how the life evolution on Earth. So if you like this topic and this talk, I really highly recommend for you to read his book, because the second half of his book really messes with your head, where he's thinking what's going to happen in 10,000 years and what are the possible scenarios for development of AIs. But I'll try to stay a little bit more on Earth for this time. So his definition of intelligence, not artificial, forget about artificial, but it's basically the ability to accomplish complex goals. So, and I pulled up also the definition from Oxford. This is just standard dictionary definition, the ability to acquire and apply knowledge and skills. So it's still also broad, relatively broad, general. I think we can all agree this could describe intelligence, and could describe, you know, like biological, us, human intelligence, but also machine intelligence. So it starts to, there is no more divide, artificial, not artificial. It kind of starts to, you know, when you take the artificial away, it starts to be the same. So how do you measure intelligence when we start going into this? There is a bunch of weird tests and scientific tests for measuring intelligence. We all know the IQ test. You cannot measure intelligence because it just measures one thing. Yeah? It's like one number. There is a Turing test. Turing is a quite known mathematician. He helped to crack Enigma during the war. Died under horrific circumstances, but he died in 55. So you think this is like, there were no computers, and people were already then kind of investigating the topic of artificial intelligence. They've never seen it work. It's nothing like NLP, speech recognition at this time, but they already were thinking about it. And Turing proposed this Turing test. He said, like, how can you differentiate if something is intelligent or not? Just by using a text interface. So, you know, you ask questions, and then the other side, you don't see your counterpart, who you're talking to, and then you just listen to the answers. And the two tests was proposing that just by talking to something, if a human being would be able to differentiate, are you talking to a human or are you talking to a machine? Well, this test apparently is not that great. There was some chatbot, I think in 2014, called Eugene Gossman, who was described as I'm a 13-year-old Ukrainian boy, and actually 33% of judges could not differentiate if they were talking to a human or to a machine. So not good. There is a weird test for machine intelligence which is called the coffee test, the coffee machine test. So imagine a robot, you put him into the kitchen and he should make coffee. He's never seen a coffee machine, just needs to figure it out. That some people also postulate this is a test, like this is really good machine intelligence if you can make coffee. I sometimes struggle with it, but these days it's easier because you just press a button. But the old machines, no way. I mean, the Italian proper machine, I cannot do it. So I would fail. Then all these tests kind of went a little bit further. There is something called Vinograd test, which really starts messing with your head of how you understand the speech, and really the same sentence, almost by just flipping one word, has a different meaning. And then if you are interested, I challenge you to kind of look it up, Vinograd test. And then there was one, I like the concept, this is also used in this book of Max Tegmark, Life 3.0. There was this concept from Hans Moravec, who is a like a professor in American university. And he started already in the 60s, like many years ago, to kind of write stuff, work on robotics, write futurist stuff. And he was comparing the intelligence like think of like a hilly kind of landscape, and the level of artificial intelligence, imagine it as water. So as the water level rises, it's kind of flooding some of the skills that humans have. So he says, don't look at it one-dimensionally. It's just more difficult for some things for the artificial intelligence to master. So in this case, we know that arithmetic computers are way better than us, so we just flooded us already. Chess, this has been many years ago, the computers are winning. There was the AlphaGo that won with Lee Sedol, which people thought this is not possible to win over a human because the game has there's no compute power could calculate all the combinations that you have in Go. So we thought like you need the creativity. There's no way computers can win. Well, actually, AlphaGo won over the best player ever. Vision is already solved. Driving, almost there. We're kind of starting to get flooded. But the creative things, stuff like art, cinematography, book writing, Turing test also not yet there. Vinograd test not yet there. Investment flooded long time ago. And science, programming, so some luck for us, programming is still far away. You see there's the AI design, it's a little bit high up. You will understand later why I put it up there. So basically as the level rises, there's more things that the AIs will be able to do. And it's kind of being proven over the years that like with every year kind of new stuff is possible using AI. So the question, what's going to happen further? So there is a concept of so-called AI winter, because as you remember, Turing, he started talking about it in the 50s, and a lot of research started there already. And then we had like first computers, so there was like the first AI winter actually happened in the 70s to the 80s. There was like 10 years of suddenly people, there was a lot of boom, and then it died off. And it was again second AI winter, but now, so what's changed now? Why we won't have another AI winter? I actually claim there will be no more AI winter. And the key difference between what it was in the past and what's happening now is actually a confluence of multiple effects. First of all, the emergence of deep learning. We didn't have deep learning. This is completely new concept that has really proven to solve a lot of problems that we could not in the old days of artificial intelligence. The compute power, the cost of computation and cost of memory, these costs, like in the last 20 years, they've, this magnitude, order of magnitude lower, so millions times cheaper now to do computation. So all these complex machine learning algorithmic calculations can be done like really cheap. And then deep learning, it requires a lot of, you need to teach it. And the good thing for us is that these machine learning algorithms and neural networks, they're not so complicated, and they're far away from human capabilities to learn. So humans can learn based on very few examples. These machine learning algorithms need way more data to become useful. For instance, the AlphaGo algorithm, to teach it to play, it was fed about 30 million like different moves, not parties, but moves in Go. And then what they did, they also let this AlphaGo play against each other. So they kind of had two computers and let it play against each other. Like a good Go player will play probably a few thousand, not moves, but games. So the machine has, seen way more games than any human being has ever seen. So they're still way behind us. But look at the data explosion, yeah? The internet, how much pictures there are, how much text there are. This is all available. So we have really this confluence of deep learning, cheap compute power, multifaceted data sets. Social networks provide so much data for the machine learning. It's amazing, yeah? And then you have also the democratization of access to these algorithms. Anyone can today, you just need Amazon account, can log in, and a little bit of programming, you could download the TensorFlow and start playing with it. And even it goes even further. There's AutoML. There are tools that make it easy without having very heavy scientific approach to use this technology. So way more people can actually work on it, and kind of without very specific technical knowledge. In the past, you could do something with AI only if you're a researcher. You need to kind of learn and research it for years. Today, you can go and start a hackathon, and 2 days later you have a use case working. So, confluence all of this, I believe it's unstoppable. It's gonna continue, and we're gonna see new developments all the time. So what's next? This is interesting. This is where we start kind of going a bit crazy. The first wave of artificial intelligence. I call it the first wave because this was algorithms that people called artificial intelligence, but they were custom engineered. For instance, like an algorithm that was winning chess. it was just able to calculate more moves in advance than a human player could, and kind of tested out which move, like if it could think of 10 moves ahead, fine. So we knew there was an insight, we knew how a strategy is. Remember the breakout game? You could program the computer to really always try this, but so there was no insight. So there was a custom engineered algorithms to solve a problem, and then they could be as good or better than humans, but only in one area. It had to be really custom engineered, designed for this one purpose. What's happening today, and this is called like the good old-fashioned artificial intelligence, so very narrow, very weak. But if you see, it's actually a common term, good old-fashioned AI. Now what we experience today is the second wave. So this is the machine learning wave, deep learning. It's called artificial narrow intelligence. It's called narrow intelligence because it can also solve only one problem. Yeah? It can recognize pictures or it can recognize speech, but try to have the speech recognition algorithm make coffee. It's not going to do it. Yeah? It's no way, won't work. And these algorithms can be as good or better as humans, but only in one area. So scientists and people researching this think this is not going to scale because it still requires specific. You need to kind of, for everything, find like a special way to transform this into mathematical model and then kind of apply the machine learning. So it's quite costly. So it is okay, and it's going to help with areas where there is a big return on investment. So if we can really improve some processes very well, then this is where the investment will go, and people will just, so this can go for on and on. This is what's happening today. But the really holy grail of artificial intelligence researchers is artificial general intelligence. And that's basically a third wave. No one knows how to do it. We think it's not going to be based on machine learning. There's a lot of research papers again on this. Some people say it should be like some cognitive architecture, so kind of closer to the human brain, how this works. But the idea is that it's really generic intelligence, which means you have an algorithm that you can teach anything. It can do the coffee, recognize speech, recognize voice, and also talk to the customer when it's on the other end of a chatbot. And the difference between narrow and general is it should be as good or better as humans in any area. There's been, again, no one knows how to do it. The architecture doesn't exist for it. But there's a ton of research and a ton of futurologists who are kind of thinking about it. And there's a ton of money going into developing this stuff. Some people think it's never going to happen. Some people think it will happen actually in our lifetime. There was some summer, I think, like the most leading AI researchers think that we might achieve artificial general intelligence in 2055. And then I think this was like 2 years ago when there was like some symposium, and then last year when they did the same guys, they think it's going to be not 2047. So we're becoming more optimistic that this may happen. Okay, cool. Now, the really mind-boggling stuff is the fourth thing, which is sometimes called technological singularity. So if you remember, imagine this. And let's say someone designs an artificial intelligence that can design other artificial intelligences. And you have almost unlimited compute power. Yeah? So you know Agile, yeah? So we can do something once, then we do it a little bit better, then we do it again a little bit better. So imagine the same concept applied to creation of an AI. So you could basically achieve like exponential growth. And this is what's called the technical singularity. That is like, you have a critical mass like in a nuclear explosion. When there's enough of the atoms together, it just generates a huge explosion and huge energy disruption. Same concept, just applied to intelligence. And this is something that we believe it would greatly exceed cognitive performance of humans in any area. Yeah? So major, again, people think that the time between this and the other one is not going to be so long. So the real key question for us is when we're going to have the artificial intelligence. But I think this is interesting. So the jobs question. What does it mean for us today, in today's market? How does this impact the society in us in general, the artificial intelligence? So few good things. So obviously, if we ever achieve the artificial general intelligence, then artificial intelligence could do anything you want. Could replace us, but still long way to go with this. So we shouldn't be that as afraid of it. But give me a few data. What are today the adoption barriers for artificial intelligence? And the companies and people who are dealing with artificial intelligence, they say the two main adoption barriers. One is there's no skill, so not enough data scientists. So obviously, if you kind of are interested in this career, this is obviously today a blocker, but it's an opportunity for jobs. So I believe that there will be an increase of, and there is already a big section on getting the people that have skills of the data science skills. And then the other thing is interesting. It's not people. It's actually the data. This machine learning algorithms, they need labeled data. They need kind of someone to provide the data to teach them. Like this AlphaGo, there was a database of 30 million moves, and then it kind of became better than a human. But there's a lot of areas where we just don't have enough data. So there's going to be a lot of jobs emerging and interesting tasks emerging to kind of create this data, crowdsource it. There's a concept coming up of something called like a citizen data gathering that normal people could actually help by providing the data. So there will be probably a lot of jobs created because of this. There's another interesting study that has been also made by Gartner, and 3/4 of people are afraid that the AI will take jobs away. So it's gonna, because it optimizes and decreases the amount of work that needs to be done by humans. But this is among people who never worked with AI. But the people who have actual experience with AI, only 1/8 of them are afraid of it. So it's probably not that bad. So you will fear what you don't know. But if you know it, it's not that scary. But the quick question, the key jobs question is, will humans eventually become unemployable? There is this, again, interesting concept that someone called the digital Athens. In the old times, in ancient Athens, there were these people who had slaves, and the slaves did all the work. And he says, like, the digital Athens is, imagine a situation where you have robots, and they are intelligent, smart, they can do anything. So we people could just sip drinks, and the robots would do everything for us. So will this happen? Again, I don't know. So this kind of starts to, I hope, mess with your head a little bit. What's going to happen here? And there's this company, Boston Dynamics, doing, there's this cheetah that jumps. I recently, like 2 days ago, they published a video with like the Atlas, which is like a human type of robot that actually does, it jumps. Luckily, I've read at least 3 different research reports. The overall consensus is that in the next 20 years, no, next 10 years. So it's an interesting thing. I also read this somewhere that if someone claims to know what's going to happen with AI and jobs beyond 10 years, then just smile polite and walk away. So there is a lot of kind of forecast, but up to 10 years. No one is really willing to forecast above 10 years. But in the 10 years, the common consensus is that AIs are going to actually create more works than it takes away. So there is some hope, but no one can tell what's going to happen, more than 10 years ahead. I wanted to talk about how AI is also impacting us today. So there's a little bit small topic that I wanted to also start thinking. So we have jobs, hard to tell what's going to happen. But this is like a timeline from 2018 of stuff that's been happening in AI. So it's impacting our lives today. There are, you probably, I don't know if you've seen, there was a movie on Netflix, The Great Hack, about Cambridge Analytica. These people, and it's a common, this is like a weapon type of technology, they influence governments. They influence how elections have been done. It's proven that they've won election in Trinidad and Tobago, and They helped in elections in US for a senator, and then they were messing around with Trump's election. So this is huge stuff. It's really impacting our lives. There's cases where AI is used in you have self-driving cars kills pedestrian. There are projects where AI is being used, like in weapon systems. There are projects for AI that are being used in just tracking people, like in China, or rating people. So it's real, and it's impacting us in different countries. So people start thinking about ethics of AI. And there is a lot of risks associated with AI. There's a risk. People need to know, ask ourselves about trust. Can we trust AI? There are, if it's an AI that recognizes, cancer, and you might make some decisions or do something based on the AI's recommendation. Can you trust it? Can you explain? So we need to be able to explain why an AI did something, especially when it can do harm. If it's just speech recognition, maybe not that important, but if it's driving a car and makes a mistake and kills someone, then we need to know why it happened. And there is a lot of research again going into it, which shows that it's very easy to trick those AIs today. I've seen a picture, for instance, there was a picture recognition of a husky and a wolf. They look very similar. The AI was quite good at recognizing which one is husky, which one is a wolf. And then someone started looking why, and they figured out that if you show a husky, they are usually, on the background is some snow, because they're like in the cold country. So actually the AI was making differentiation not by differentiating the face of the thing, but just because there was snow on the picture as well. So imagine, making decisions like this for something that's important, when the AI is running a power grid for the country, yeah, or controlling some nuclear weapons. Scary shit. So liability. If you have a self-driving car today, if you drive into pedestrian, or drive in, let's say, you hit someone, it's relatively easy to figure out who's guilty. But if it's the self-driving car, who's guilty? Whose liability is it? Is it you as a driver of a car? You didn't do anything wrong. Is this the company that provided you with the car? Will the cars have insurance, or will the company? Who owns the insurance? But if we start thinking about AI in, like some creative stuff, so who owns the invention? If a car can have, and a self-driving car can be insured, what do you? So there's a lot of questions. Security, control, you can think where I'm going, yeah? So how do you control, like with weapon stuff? It's a big deal. So people are saying we need AI governance, and companies are actually agreeing to it. So for instance, Google has published like their principles for AI ethics. It's weird, but people really think about AI ethics, and organizations are moving towards a responsible and ethical use of AI. 92% of companies that are leading in AI are actually training their data scientists in ethics. Ethics, because you need to know, are you able to use like personal data, and to what extent you can use the personal data of people. Don't use it to kill people. Don't use it to harm people. So, and then actually, same study was showing that 74% of AI leaders recognize that a close oversight of AI technologies is necessary, because we're starting to play with very, very powerful thing when those AIs are controlling big things like weapons or power grids, or you have the same program kind of controlling all the traffic. It's no longer a breakout play where it messes up, then it just wins a little bit points. There can be people's lives are involved here. So there's a common belief that we need some AI governance, we need some AI ethic rules that need to be followed. Those need to be programmed into the computers. There's this Isaac Asimov, you probably remember, there were rights for robots, there's this robot laws. It's simply science fiction that today we have to really start thinking about and make it very prescriptive of how to control this technology. I'm actually very against controlling anything, but when you start let your mind flow, it starts to be really, really almost scary. But the real important question, and the existential question in my view for us, the most controversial question of our time, is the one that I gave you answer from the leading AI scientists, and that's basically, will there be a human level AI, and when this will happen? So that's, and again, there are very various scenarios that are in the world, kind of people thinking of what will happen if this will ever happen. So I'm going to show a very funny video and then we're done. So, this is a fake, obviously, but just to show something funny. So don't mess with robots. Okay, so Irving J. Good is actually a good friend of Alan Turing. In '65, he died in, so like really many times ago, but many years ago. But he basically put this sentence that I want to kind of say goodbye to you. The first ultra-intelligent machine is the last invention that man ever need make, provided that the machine is docile enough to tell us how to keep it under control. Thank you.